All right, and number 3 on the written exercises of 8.6, let me put written exercise up here just as a reminder. You're given these -2 and -1 plus I, and you're supposed to find a cubic equation. Well, if it's a cubic equation, that means it's got 3 factors that look like x plus or minus something, because it would take 3 of those to get you an x cubed. Find a cubic equation with integral coefficients, that means they don't want any fractions or anything, that has the given numbers as roots. Okay, so if I'm going to do this, -2 comes from x plus 2, because if you take x plus 2 and set it equal to 0, you'd get -2. So there's one factor. Now, what about this one? Well, there's 2 things I know about this. First of all, if I have -1 plus I as a root, because it's an imaginary number, then on page 377, the conjugate root theorem says that -1 minus I is also going to be a root. So this is a root, and then we're going to also have this root. What does that look like when I go to factor? It looks like this. It would be x minus -1 plus I would be for the middle one. And then the one in red, I'll write it in red. And it would be x minus -1 minus I. Okay. So we've got this, and what we got to do with it, now that we've written the factors down, because the factors are always x minus whatever the number is. They're in the form x minus h when you write them. So if I put, for instance, that's how I got the plus 2. X minus -2 gave me this x plus 2 over here. So that's why I wrote the other 2 the way that I did. Okay, now this is going to be kind of fun because we got to multiply all that out. Let's start with just doing these 2 together because they're kind of the nasty ones, and I think if we do those first, they're going to simplify a lot more than you might think. First of all, let's say that's x minus -1 would be x plus 1, and then minus I. Okay, so I'm going to distribute the subtraction sign inside of the middle parentheses. Over here where the red one is, and I'll do it again in red just to kind of emphasize where I'm at, it's x, and this minus, when you distribute it to the -1, becomes a plus 1, and the minus, when you distribute it to the minus I, becomes a plus I. So now we got to multiply all that together. These are equal to each other. Okay, so I'm going to put equal. I'm going to keep up with my x plus 2, and I'm going to start distributing. I'm going to work on doing these 2. I'm going to multiply them out first, because what happens is when you do this, it usually turns a whole lot simpler than it looks like it's going to. So here we go. X times x is x squared. X times 1 is x. X times I is ix. Now we're going to distribute the plus 1. Plus 1 times x is just plus 1x. I'll just put x. 1 times 1 is 1, and positive 1 times a positive I is another I. Okay, so now we're going to distribute this minus I here. Minus I times x is a minus ix. Minus I times a positive 1 would be minus I. And minus I times plus I would be minus I squared. Yuck, you say. Well, let's see what's going to happen. Usually a lot of things cancel out or combine. So let me go ahead and just keep writing down this x plus 2 here. And if we kind of condense what's inside here, we have an x squared. I'm going to mark stuff out as I do it. There was the x squared. There's a plus x and another plus x, and I don't see any more x's, so that's plus 2x. Okay, so I'm going to mark those out. I have a plus ix and a minus ix, so those are going to cancel out. I have a plus I and a minus I, so those 2 cancel out. And so what I have left, the only thing I got left is a plus 1, and I've got that minus I squared at the end. Okay, but do you remember that I squared is the same thing as -1? Okay, so it's a plus 1 now. I've got this plus 1 here, but then I've got minus -1. I squared is -1. Well, what is 1 minus -1? These 2 numbers here at the end, they're going to become 1 plus 1, which is 2. So what I have is x plus 2, just copying that down, and then x squared plus 2x, and then that's going to be a plus 2. Okay, we are almost there. We've got to keep multiplying it out because they want a whole equation. They don't want it in factored form. So now we're going to distribute. I'm going to start up here and distribute this x times everything in the second parentheses. So that's going to be, I'm going to come over here and write it, x cubed, because x to the first times x squared is x cubed. X times 2x is 2x squared. X times 2 is 2x. Now, let's distribute the 2. I'll do that in blue, okay? 2 times x squared is 2x squared. 2 times 2x is 4x. I'll have to squeeze this other one in here. 2 times 2 is 4. Okay, so let's clean it up. We're almost done. We've only got one x cubed term, so we write it down. I'm going to cross it out once I do it. Now I've got a 2x squared and a 2x squared, which makes a 4x squared. So that took care of that one and that one. I have 2x and 4x, that is 6x, and that took care of that, and now I've just got plus 4. And I checked it and it's correct, yay, because you know what? This isn't hard, it's just tedious, and you know, it's a lot of distributing and a lot of combining like terms, so you can see that it'd be really easy to make a mistake, and it would just affect you from there on out, wouldn't it? So you just got to be careful, you got to go slow, check your answer, back up if you find it's not right, and just, you know, maybe start over and just carefully see what you did, and you'll probably find your mistake. That's the only thing is this is easy to make a mistake on. All right, number 3 took a long time. Number 7 is going to be fast. It says all but one of the equation's roots are given. And the roots are those numbers I listed there. Remember, they're the solutions. Find the remaining root and check your answer by substituting it for x in the equation. All right, if you remember, the conjugate root theorem said if I've got this as a root, then the other root's going to be 1 plus 2i. So that's the missing root. Now what they want us to do is to check our answer and show that that really does work. Prove it to me, they're saying, okay? Here you go, yay. And I'm thinking the same thing. So if I put this in, I've got 1 plus 2i. I'm substituting this whole thing here in for x. So I've got everywhere I see an x, I've got to put in 1 plus 2i. This is going to be fun. I'm kidding. I thought number 7 it's fast to get the answer, but the checking is not going to be fast. Because everywhere we see an x, we're plugging in a 1 plus 2i. And then minus 5. And we're supposed to show that it equals 0. So let's see if it does. All right, the bad thing about this is when you see 1 plus 2i to the 4th right here, that means you've got to write down 4 copies of that and multiply it out. You know what I'm going to do? Because we've got a square, why don't I do this? Let's stop for a minute here and let's build on this. You notice that I got to plug it in as a square and a cube and a 4th degree, so why don't we just, as we go, 1 plus 2i squared would be 1 plus 2i times 1 plus 2i. Let's figure that out, and then we'll just multiply it by another one to get the cube, and then by another one to get the 4th one. That would probably be the fastest way to do this and keep us from maybe being so upset about what this means we have to do. 1 times 1 is 1. 1 plus 2i is 2i. And then 2i times 1 is another 2i. And 2i times 2i is 4i squared. Well, that's going to simplify to 1 plus 4i. And then plus 4, and I squared is negative 1, so we'd say, okay, we can simplify that because 4 times negative 1 is a negative 4. 1 plus negative 4 would be negative 3, so this would be negative 3 plus 4i. That's the square, okay? And I'm going to have to keep up with this on a piece of paper because I know I'm going to. So if you have 1 plus 2i squared, it's equal to negative 3 plus 4i. Okay, so I'll go plug all this in a minute, but let's just do as much as we can here off to the side before we put it all together. Okay, if we take the square term here and we multiply it by another 1 plus 2i, we would get the 1 plus 2i cubed. And again, in a minute, I'm going to go plug that in up here. So this will keep us from having to redo so much work. 1 times negative 3 is negative 3. 1 times 4i is 4i. 2i times negative 3 would be negative 6i, and 2i times 4i would be 8i squared. But we know that I squared is negative 1, so it's going to be a negative 3 plus a negative 8. That's going to give us a negative 11. And then if you combine your I terms, 4i minus 6i here would be minus 2i. So that's what we get when we cube it. So I'm going to circle that. Hopefully we won't run out of time here. 1 times negative 11, this would be to the 4th power because I took to the 3rd power and I'm just multiplying it by another 1 plus 2i. So 1 times negative 11 is negative 11. 1 times minus 2i is minus 2i. 2i times minus 11 is minus 22i. And 2i times minus 2i would be minus 4i squared, but I know that I squared is negative 1, so I'm just going to try to save some room there. So negative 4 times negative 1 is going to be a plus 4. A negative 11 plus 4 would be a negative 7, and minus 2i minus 22 more I would be minus 24i. That's to the 4th power right there. Okay, so this was the original problem, and we've got some pieces of it now, and I'll kind of color code the pieces. 1 plus 2i to the 4th ended up being negative 7 minus 24i. Okay? Now I'm going to subtract, I'll do that in a different color. Minus 2 times 1 plus 2i cubed ended up being negative 11 minus 2i. That's what we were doing on that other page that we just did. Now we've got plus 4 times 1 plus 2i squared. Well, 1 plus 2i squared was negative 3 plus 4i. If you see that I've made a mistake rewriting it, it's because I'm trying to read really small writing on previous slides. I can never go back to a slide. So if there was a mistake here, just take that into account and do it right on your paper. Now I've got plus 2, let me do that in a different color, plus 2 times 1 plus 2i. We didn't do anything with that. And then minus 5. So let's simplify all this. All right. You got negative 7 minus 24i, and then negative 2 times negative 11 is plus 22. Negative 2 times negative 2i is plus 4i. And then we got 4 times negative 3 is negative 12, and 4 times 4i is 16i. I'm going fast because I know I'm going to run out of time. 2 times 1 is 2. 2 times 2i is plus 4i, and then we got minus 5. Okay, so let's add all the numbers together. I'm going to turn the video off so that I can do that. Okay, so if you take all the numbers here, and I went off just to check this on side paper, it's all these numbers here, just the constants, and you add them up, they add up to 0. Okay, so that's 0. Now let's look at all the I terms. I've got minus 24i plus 4i. That would give me minus 20i. Minus 20i plus 16i would be minus 4i, and minus 4i plus 4i would be 0i, so it's just 0 plus 0 is 0. Did it work? Yes, because when I plugged it in, I got 0. Whew! Wouldn't you hate to make a mistake on all that? It's also going to... Now, the problem itself was easy. The checking was horrendous. Yeah, just keep that in mind. Go through it one time with deep pain, and you won't have to do it again.